Let's learn tangent theorem. A tangent at any point of circle is perpendicular to the radius at the point of contact. Okay. According to the situation, let's consider in a circle with center O, line L is a tangent at point A. Therefore, seg OA will be the radius at the point of contact. Let's write given and to prove. Given in circle with center O, line L is tangent at point A. To prove, line L perpendicular seg OA. Now let's give its proof, which is indirect proof by the method of indirect proof. Okay, suppose line L is not perpendicular to seg OA. Let seg O be perpendicular line L. Obviously, B be the distinct from A. Let's try to draw a diagram. O is the center, A be the point on line L, but line L is not perpendicular to seg OA. That's why seg OB perpendicular to line L. Let us suppose take a point C on line L such that A dash B dash C and BA equals BC. Okay, let's take such a point C on line L such that A dash B dash C and BA equals BC. Draw seg OC. Okay. Therefore, in a triangle OBA and a triangle OBC, in triangle OBA and triangle OBC, BA congruent BC, since construction angle OBA congruent angle OBC, since each 90 degree, OB congruent OB, since common side. Okay, now you may note these two triangles are congruent by SAS test. Therefore, we can mention, therefore, triangle OBA congruent triangle OBC by SAS test. And we know that if two triangles are congruent, then their corresponding elements are congruent. Therefore, OA congruent OC, since corresponding sides of congruent triangle, and therefore OA equals OC. But OA is a radius of circle, and therefore OC is also radius of circle. Therefore C also lies on circle, and therefore line L and circle with center O have 2 points in common, that is A and C. But line L is a tangent, and therefore they must have one and only one point in common, and therefore our assumption is wrong, that is seg, that is line L is not perpendicular to seg OA is wrong, and therefore line L perpendicular to seg OA is right. Now let's see converse of tangent theorem. Converse of tangent theorem. A line perpendicular to the radius at a point on a circle is tangent to that circle. Okay. According to this situation, let's consider a circle with center M. Line L is such a line that it is perpendicular to radius m1. It is perpendicular to the radius m1 at point N, where N is a point on a circle. We are interested to prove this line L is a tangent. Okay, let's mention given to prove and proof. Given in circle with center M, seg m1 is a radius. Line L perpendicular seg m1 at point N. To prove line L is a tangent. Okay, now we know that a tangent is a line in a plane of a circle having one and only one point common with a circle. Means we are interested to prove N is a point which lies on line L as well as on a circle. Okay, that's why in a proof, let P be the point on line L other than N. Okay, let's suppose it is that point P. Draw seg MP. Draw seg MP. Okay, let's draw seg MP. And therefore, in a triangle MNP, angle MNP equals 90 degree. And therefore, triangle MNP is a right angled triangle. We know that in a right angled triangle, hypotenuse is the longest side. Okay, and therefore here you may note seg MP is the hypotenuse, and therefore seg MP will be greater than seg MN. Therefore seg MP is greater than seg MN, and therefore MP is greater than radius, and therefore P does not lie on circle, and therefore line L and circle with center M have one and only one point in common, that is point N, and therefore by definition of tangent, line L is a tangent. Line L is a tangent. to the circle.